benzoin condensation. So now we are going to be see the second condensation reaction, that is the Knoevenagel condensation. In Knoevenagel condensation, the basic requirement is what? It is the active methylene group. So this is the general representation of the benzoin condensation, Knoevenagel condensation. So Knoevenagel condensation is a nucleophilic addition of an active hydrogen compound to a carbonyl group followed by the dehydration reaction, in which a molecule of the water is going to be eliminated. So this will be called as what? Knoevenagel condensation. In this reaction there is a elimination of water molecule, so it will be called as what? Condensation. The basic requirement is what? It is the active methylene compound on reaction with carbonyl compound like aldehyde or ketone will give the formation of the product with dehydration, called as the Knoevenagel condensation. The product is often an alpha beta conjugated enone system. Knoevenagel reaction is modified of the aldol condensation reaction. It is a modification of aldol condensation reaction. The active hydrogen compound used should be the ZCH2Z. That means both the Z group will be the electron withdrawing group, making this CH2 as the active methylene compound. And this is the general representation. This is the active methylene group where Z is the electron withdrawing group, making this carbon as the acidic proton, and it can easily give the condensation reaction with loss of water molecule, and we are going to get formation of the alpha beta unsaturated enone molecule. Now some of the active methylene group which are going to be utilized into the condensation reaction are the diethyl malonate, malonic acid, and ethyl acetate, ethyl acetoacetate, as well as the diethyl malonate. So this is the diethyl malonate, this is the malonic acid, and Z we have already discussed that Z should be the strong electron withdrawing group like cyanide, nitro, etc. Using a strong base in this reaction will induce the self condensation of the aldehyde and ketone. The carbonyl group which are going to be utilized into the Knoevenagel condensation will be preferably only aldehyde or a ketone. So like acetaldehyde, acetone can be undergo this reaction. The catalyst is usually a weak base amine like pyridine. Now this is the general representation of the Knoevenagel reaction. So in which we already discussed that active methylene group on reaction with aldehyde or ketone in basic condition will give the formation of the alpha beta unsaturated enone system. This is the Knoevenagel reaction. And if we will go for further application of this reaction can give the hydrolysis of ester, and we can get formation of the alpha beta unsaturated carboxylic acid. So formation of alpha beta unsaturated carboxylic acid is the application of the Knoevenagel reaction. So in simple language, Knoevenagel condensation is the nucleophilic addition of an active hydrogen compound to a carbonyl group like aldehyde or ketone, followed by the dehydration reaction in which a molecule of water is going to be eliminated. So that's why this reaction will be called as the Knoevenagel condensation, and the product is often an alpha beta conjugated enone system. So if you are going to be see the mechanism of Knoevenagel condensation, so first step is an enol intermediate is going to be formed. So as we have discussed into the previous slides that alpha beta unsaturated compound is going to be reacted with active methylene. So in first step, so active methylene group like diethyl malonate, which on reaction with the base, so because of the strong electron withdrawing group, this carbon is going to become the active methylene, and this proton is going to become acidic. So base is going to be easily pick up this acidic proton, will give the formation of the carbanion. That carbanion can give the formation of the enolate ion. So the first step of the Knoevenagel condensation is the formation of enolate ion. Second step, the step second is the enol form reacts with the aldehyde and the resulting aldol undergoes the base induced elimination. That means in a second step, the enolate ion which has been formed into the first step will react with the carbonyl compound like aldehyde or ketone, and the resulting compound form will be the aldol product, which on dehydration will give the formation of the expected product. So this is the first step that we already discussed into the previous slide, formation of enolate ion or the carbanion. So that carbanion is going to be attacked towards the aldehyde or ketone, will give the formation of this intermediate. This alkoxide ion will pick up the proton from this conjugated acid of the piperidine, and we are going to be get formation of this intermediate. So there is a OH and this hydrogen. So this OH and this hydrogen will be lost as the water molecule in presence of the piperidine as the base catalyst, and we are going to get formation of alpha beta unsaturated enone system. So this is the Knoevenagel condensation. So what is the scope of Knoevenagel condensation? The scope of Knoevenagel condensation, it is that it is the key step in the commercial production of the anti-malarial drug like lumefantrine. Knoevenagel condensation used in the synthesis of the conjugated enone